Hello Internet, welcome to another tutorial in digital electronics series. We are discussing half subtractor today. It's a pretty simple circuit, combinational circuit of digital electronics that performs a very simple function of subtracting two bits. So by definition it's a logic circuit that subtracts two bits, and the cases that are formed out of subtracting two bits are these. The first case could be when we wish to subtract a 0 from a 0. If we wish to subtract a 0 from 0, we do not need to take any borrow, and the difference will be 0. So I'll say the difference is 0 and I do not have to take any borrow. The second case could be if you wish to subtract a 0 from a 1. Again, in this case also we do not need to take any borrow, and the difference will be 1, because when we subtract 1 from a 0, the difference is 1. And the third case could be when we wish to subtract 1 from a 1, the difference will stand 0 and we still do not need to borrow anything. But there is this last case where we wish to subtract a 1 from a 0. In this case we'll need to take one borrow here. So this borrowed 1 will make it 2. So 1 0 is 2. If we subtract 1 from 2, we get a difference of 1, and of course a borrow is needed to be taken. So these are the four cases for a half subtractor. This is what half subtractor is intended to do. So if we were to draw the truth table out of it, we could assume two inputs, then difference and borrow, and we'll assume that B is being subtracted from A. So we'll have four cases: 0 0 0 1 1 0 and 1 1. And in all these four cases we know that borrow is only taken when a 1 is subtracted from 0, and rest in all the cases the borrow is 0 and the difference is 0 here and a 1 here and a 1 here and a 0 here. Now if you look at the truth table closely and we'll look at, or we'll focus at the truth table for difference, it surely does look like a truth table of a popular gate, which is XOR gate. But otherwise also you can formulate an expression for difference using a K-map. And if you look at the expression for borrow, so this does not look like any popular ready-made gate expression. So what we'll do is we'll make K maps for both difference and borrow. So for difference, A and B are two inputs. At 0 0 the difference is 0, at 0 1 the difference is 1, at 1 0 the difference is 1, at 1 1 the difference is 0. So the expression for 0 would become A XOR B, and the expanded expression is A bar B plus AB bar. And similarly for borrow, we have a 1 here at this place, and just everybody is 0, so the expression for borrow will become A bar B. So once we know the expressions of the output in terms of inputs, we can draw its logical circuit. We'll take A, B as 2 inputs. A is inverted and B is given as it is to an AND gate to make borrow, and A and B are given to an XOR gate to make difference. And this block, this logical block of 2 inputs and 2 outputs is half subtractor. So this is how simple the half subtractor is, and it'll be a building block of the full subtractor or the real life subtraction that is done on binary bits, because whenever subtraction takes place, the most likely case is a continuous string of bits being subtracted from a continuous string of bits, and in that case we'll be using full subtractor, and I'll discuss full subtractor as a separate unit, as a separate logic circuit in the next tutorial. I hope you liked this tutorial, and I'll see you in the next one. Bye.